Hello guys, welcome back to my channel. This is the Cortex and we are back at it again. We are starting the first chapter of chemistry, kinetic particle theory. This is a very important chapter, so let's get on with it. Now this is our learning objectives. States of matter, kinetic particle theory, characteristics of the state of matter, melting, freezing, boiling, condensation, evaporation. We will not be covering all of the topics. We will be covering till evaporation versus condensation in this part, and condensation, sublimation, diffusion of gases and diffusion of liquids will be in the other parts. States of matter. I am pretty sure every one of us knows what are states of matter, but we need to know exactly what are those. So matter is a substance that has mass and occupies space. Each and every living and non-living thing is matter. So basically anything that has mass and anything that takes up space is matter. Now matter can exist as a solid, liquid, gas, plasma and Bose-Einstein condensate. Now these are two new states of matter, but we will mainly look at the first three: solids, liquids and gases. Plasma and Bose-Einstein condensate are not of our level. Changes in temperature and pressure can change the states of matter. For example, in freezing water becomes ice and in boiling water becomes vapor. So this is a change in temperature. When you freeze water it becomes ice and boiling becomes vapor. Now this is one of the most important things of this chapter. You will have to learn this table about the properties of the solids, liquid and gases. Now the shape of a solid is fixed, whereas the shape of a liquid is not fixed. The liquid flows along with the gases, and the volume of the solid is fixed. Also same with the liquid, but not with the gases. Compressibility: solid cannot be compressed because its atoms are closely packed together, as you can see, whereas a liquid also cannot be compressed because it also has atoms which are very close to each other, but not as much as solids. But gas, it can be compressed because its atoms are way far apart than of liquids and of gases. Now the main topic, kinetic particle theory. So kinetic particle theory states that all matter is made up of tiny particles, atoms basically, and that these particles are in constant random motion. It describes the states of matter. It describes solid, liquid and gases, explains differences in the properties of solids, liquid and gases. So this table, it is only because of kinetic particle theory, and it explains changes in the state of matter. When we say that temperature and pressure is applied on a substance, it changes. That is also the part of kinetic particle theory. When we see in the air, we can see dust particles dancing or randomly moving in light, which justifies the kinetic particle theory. This is a very famous way to tell the kinetic particle theory, and I also say that you should write this in a question or in a paper, in the theory paper. Characteristics of the states of matter. This is the most important thing in this chapter. Now in solids, what is the arrangement of particles? They are very close together. They are packed together. They have in a regular pattern, whereas in a liquid they are close together but not as close as solids, and they move in a random arrangement, and they are present in a random arrangement, whereas gases, their atoms are very far apart and they move in a they are present in a random arrangement, whereas solids, they vibrate in their fixed positions. They are in a fixed position where they cannot move. They only vibrate on that spot. a liquid moves around each other. It does not have such forces of attraction that it cannot move away just like a gases, but it has lower forces of attraction than solids, and the atoms move around each other constantly. But whereas in gases they move in all directions, because there is not as such dense amount of atoms present, so that's why they can move wherever they want. Same with this, that the strength of attraction is very strong in solids. It is strong but less than solids, and in gases, as we know, it's very weak. Arrangement, we have discussed this: regular, random, and disorderly packing. Very closely packed, but the gases move around freely in random and in straight lines motion. These vibrate in their fixed positions. But where liquids, they slide or roll over one another randomly. But unlike gases, they are not as far apart and they have a regular movement. Unlike gases can move wherever they want. Now we are studying the processes. One of the main processes is melting. I am pretty sure we all know about this. Melting is the process by which a substance changes from a solid or the solid phase to the liquid phase. Melting occurs when the internal energy of a solid decreases, usually through the application of heat or pressure, such that the molecules become less ordered. Now see, this arrow, this is a very important. This is how you are supposed to write the process of melting. Heat energy is absorbed by the particles of the solid. The heat energy is converted into kinetic energy. Now heat energy, we all know heat, but kinetic energy, kinetic means movement. So they start to move, the particles start to vibrate. See, it says over here faster about their fixed position, because this is still a solid. When the temperature is high enough, the vibrations of the particles become sufficient to overcome the forces of attraction between them. The particles begin to break away. So when a lot of heat energy is converted into kinetic energy, there's so much kinetic energy that they vibrate a lot, which makes them overcome, or the forces of attraction start to loosen up between them and they break away from these fixed positions. So the particles are no longer in their fixed positions and the substance is now a liquid. The particle can now move freely throughout the liquid, because that is one of the main properties of the liquid state. And you see this, the heat curve. Now this is of naphthalene, and you will have to learn these temperatures. So this is from A to B. We see the temperature increases, but it is not in liquid right now, but when it reaches to B, it starts to change state and it is 80 degrees centigrade. So we know that the melting point of naphthalene is 80 degrees C, and from B to C there is no change of temperature, but the naphthalene starts to melt, and from C it has been completely melted, and now temperature changes and it actually increases and the heat rises. So as here, this is where it gradually gains heat energy. It starts to break apart from the fixed position, and now it has been free. It can move freely throughout the liquid. Freezing, also a well-known thing. The freezing is a phase transition where a liquid turns into a solid when its temperature is lowered below its freezing point. In accordance with the internationally established definition, freezing means the solidification phase change of a liquid or the liquid content of a substance, usually due to cooling. So that was a little bit complex, but you will understand. Energy is given out by the particles of a liquid, because when you cool a substance, its vibration decreases and energy is given less. So the particles lose kinetic energy because the vibrations decrease. When the temperature is low enough, the particles no longer have enough energy to move freely because they are losing so much energy that they lose the ability of moving freely. The particles start to settle into their fixed position because that is one of the properties of the solid. All the particles have settled into the fixed position. The substance is now a solid. The particle can only vibrate about their fixed position. One thing to keep in mind, the melting point of water is 0 degree centigrade, 100 degree centigrade actually, and the freezing point is 0 degree centigrade. We can see this cooling curve. Now from P, I'm sorry it's a very blurry image, from P to Q, the substance starts to lose heat. It starts to lose heat. So when it reaches Q, it no more has that much heat, and now it starts to freeze. The temperature does not change, but it starts to settle in its positions. In R, it has completely frozen, and in S, it decreases further temperature because of which that the property of these states. Boiling is the process by which a liquid turns into a vapor when it is heated to its boiling point. The change from a liquid phase to a gaseous phase occurs when the vapor pressure of the liquid is equal to the atmospheric pressure exerted on the liquid. Now, this is the same. Heat energy is absorbed by the particles of the liquid. The energy is converted into kinetic energy. The particles start to move faster as the temperature rises. When the temperature is high enough, the particles have enough energy to overcome the forces of attraction holding them together. They do not have as much forces of attraction and they can now move freely. They are far apart. It is now a gas and it can move in any direction. Now we see the heating curve. Now this is a tetrachloromethane which we are talking about. From W to X, the temperature rises. This is the same at 77 degrees centigrade. The temperature does not rise or lowers down, falls, but it starts to evaporate and or boil, whatever you say. And from Y, it has been completely evaporated, and from Y to Z, the temperature increases. This is very easy, but you should know this. Evaporation is the process by which water changes from a liquid to a gas or vapor. Evaporation is the primary pathway that water moves from the liquid state back into the water cycle as atmospheric water vapor. Now this is a side point, you do not need to remember this. Evaporation happens when a liquid substance becomes a gas. When water is heated, it evaporates. The molecules move and vibrate so quickly that they escape into the atmosphere as molecules of water vapor. Yes, heat from the sun or solar energy powers the evaporation process. This is very same. The temperature rises until point B is reached where it starts to evaporate. The same thing. This is a heating curve. The temperature does not rise, but it still evaporates. And at point C, all evaporates, and now the temperature rises. Evaporation versus condensation. In evaporation, water changes from liquid to gas, and in condensation, water vapor in the air changes from gas to liquid. Heat transfers from the environment to water molecules, whereas heat transfers from water molecules to the environment. Water molecules gain energy in evaporation, whereas water molecules lose energy in evaporation. Things air dry, we know, it's a famous saying, and glasses sweat. But whereas in both, water changes state. Heat transfers, water molecules gain or lose energy. The environment gains or loses energy. This is a very important thing, you will have to remember this. Thank you for watching my video. Thank you for supporting me, and please do not forget to see part 2. Bye.